Hey everybody, we're going to talk about money today, okay? And what we're going to do is we are going to compare two types of ways, I should say, sorry, that we invest our money, okay? And we're going to take a look at simple interest and compound interest. We're basically interested in the compound interest since it creates an exponential graph. But to compare the types of interest, that's where we're going to start, okay? And then as always, as we move through the notes, I'll let you know what's really important, okay, and what you need to focus on. So just to start, it does talk about investing money here. It says if you deposit money in a financial institution like a bank, you are in effect lending money to the bank. In exchange, the bank pays you interest. And again, as mentioned, there are two types of interest, what we call simple interest and compound interest. Okay, so when I take this simple interest, what you're going to see is when I graph it, okay, it creates a linear function, okay? And the reason being is that I'm always getting the same amount of interest every single time, okay? I do a calculation. It does not change. So 1 year goes by, I get $500. Another year goes by, I get another $500, okay? It doesn't change, and you'll see that here both in the calculations and then when we graph in a page or two, okay? So it just says simple interest is usually applicable to short-term investments of 1 year or less, or to long-term investments where the annual interest is paid to the investor and not reinvested. So for example, if you invest $500, earning an interest rate at 6% per year, how much interest would you earn in 1 year? Well, what you would do is you would take the $500 that you have, okay, and you would multiply it by the 6%, which as a decimal is 0.06, okay, and when I calculate that, that is going to give me $30, okay, so there is the interest, okay. Now, for half a year, so half a year would look like this, right? I would take the $500 that I've invested. Now, they've given me 6%, and notice it says per year. Okay, now a bank is not stupid. If you're going to collect interest half a year at a time, they're going to take the 6% that they're giving you for the year and divide it in half. So they're only going to give you 3% for the first half of the year and 3% for the second half of the year. So as a calculation, it could look like this, okay, 0.06, okay, times a half, or divided by 2, either one. Okay, same calculation, and you will see that gives you $15. Okay, not a shock, half of what it was for 1 year in the first part of the question. Now for 1 month, again, what would you do here? Well, you would take the original amount that you're investing, the $500, times 6%, and I'm going to divide that by 12. Now, why 12? Okay, well, because there's 12 months in a year. So the 6% is now being spread out evenly amongst the 12 months. So that'll tell me the interest per month times the $500, and that will give me $2.50. Okay, so they're going to take this now, this example they've used, and kind of try and generalize it using variables. So if they say in the question, R is going to be your annual interest rate as a decimal, and P dollars, okay, is the initial investment. How much interest would you earn in a year? Well, it would be the amount of money that you have invested times, okay, the interest rate as a decimal. For half a year, okay, it would be P and then R over 2, or times 1/2, okay? And for T years, so let's say it was more than 1 year, say 3 years, well then you would multiply it by T, whatever T is in terms of years, 5 years, 10 years, okay, etc. And that formula takes us to exactly what they've created here. It says the formula to calculate simple interest is I is equal to PRT, okay, where I stands for the interest, P is the principal amount of your investment, R represents the annual rate of interest as a decimal, and T is time in years, okay? So we'll take a little bit closer look at that on the next page. Or actually, there's a couple questions here before we move on to compound interest, but again, we will see that on the next page. So it reads like this: Millie invests $2,350 at 7% per year for 6 months. Calculate after 6 months the interest that Millie would have on the investment. So I follow the simple interest formula. I is equal to PRT, okay, which will be the $2,350. There's the principal amount, what she first invested. The interest rate as a decimal is 7%, okay, and for 6 months, well, that's half a year. So you can multiply that by 1/2, or like I did in some of the previous questions, divide everything by 2. It's going to be the same thing. Okay, that is going to give me, okay, when I put those in, that is going to give me $82.25. Okay, so that's just the interest. Now, B says, what's the value of her investment? So the total value of her investment would be the original amount she invested, $2,350, plus the interest she has now accumulated, which is the $82.25, the value you just calculated in part A. So taking those two together and putting them into my calculator, I get $2,432.25. And there you go. Okay, so that's how simple interest works. Pretty straightforward. That formula I equals PRT would be given to you on any kind of quiz or evaluation that I ask you to do. Okay. Now, compound interest. When I take a look at compound interest, just like above where I said simple interest was linear, this is going to create, okay, an exponential graph. Okay, and that's why we kind of are taking a look at it in this unit. In simple interest, the principal at the beginning of the second year is the same as the principal at the beginning of the first year. Okay. In compound interest, okay, which is what we are going to talk about now. So the interest earned during the first year is added, okay, to the original principal to form a new principal. So every year you have a new starting amount. To understand the comparison between simple and compound interest, we're going to take a look at the comparison in the next 3 pages, okay? So exploring simple interest and compound interest. Okay, so it says a bank offers 2 types of savings bonds: a regular saving bond, which is 9% PA. Now PA stands for per annum, okay, which is the same thing as per year. Compound savings bond is 9% again, PA per annum, but you'll notice they tell you how often you're going to collect your interest, and it's compounded annually. So every year is once a year. So consider an initial investment of $15,000 in each bond. Okay, so we're going to start here, okay, by talking about simple interest. Okay, so it says the simple interest each year is 9% of $15,000. So if I were to calculate that, okay, that would just be the 0.09 times 15,000. Okay, and when I do that, that will give me $1,350. So $1,350. So what happens is part B now says complete the table. Well, if this is simple interest, what you're going to figure out is that every year you are going to be adding $1,350. Then the next year you will also add $1,350, okay? And so on and so on. Okay, so to get the next couple of calculations in the column, that's exactly what I'm going to do. So the first one, I would take 21,750 and add the interest of 1,350, and that'll give you 23,100. Okay, and then do it again. So add another 1,350, and you'll get 24,450, and then one final time. So one more time, 1,350, and I get $25,000, 800 exactly. Okay, so there I filled in the chart and done what they asked me to do. Okay, now compound interest, a little more complicated, but I will walk you through it and it will be super clear. Okay, so complete the following to determine the compound interest and the value of the bond. So what happens at the end of year one, as you can see, they take the principal, okay, which was the $15,000, and to that they're going to add the interest. Well, how do you get interest? You take the original amount and multiply it by the interest rate. Okay, so what they've done now, and what you can see I've underlined in blue, is that I actually have 2 terms. I have 15,000 and then plus 15,000 times 0.09. Well, what's common to both of those terms is $15,000. You can see it here in the first term, and you can see it here in the second term. So what they do is they factor it out of those 2 terms. If I factor $15,000 out of each of those terms, I'm just left with 1 plus 0.09, which is which is, okay, right here. Okay, so there's the factoring out, and there's what's left when I factor out the 15,000, and then I just add the 1 plus 0.09 to get 1.09 right there. So there is an expression for the amount of money I will have at the end of year one. Now what you'll notice here as I move through the questions, at the end of year one, okay, exponent of 1. When I move down to year 2 here, you'll see that I end up with an exponent of 2. Okay, and at the end of year 3, guess what? Well, I'm going to end up with something that has an exponent of 3. Okay, and we will get there. Now, in year 2, remember what happens is that the amount I ended up with at the end of year 1 is now my principal at the beginning of year 2. So that's why I have 15,001.09 as my starting amount. I have that amount again right there, but I have to calculate the interest on it. So I multiply it by 9%. Again, I have two terms. I factor out what's common to those two terms, which is the 15,001.09. Both terms have that. What's left when I factor that out is 1 plus 0.09, okay, which when I add them, I get 1.09 again. Now I have two of those. That's why it's 1.09 squared, okay? I know that these calculations are a little tricky. You're never going to be asked to do these calculations, okay? Again, this is just the process of how we are getting the expressions for the amount of money we have at the end of the year. I will again let you know what's super important, what you need to highlight and make sure you know for any tests that are coming up. See, and on the side here, they're even telling us what to do in the next question, okay? But what you'll notice again is that the final amount in year 2 becomes my principal, okay? Amount at the start of year 3. So there's my principal amount, okay? There it is again, but now I have to calculate interest on it. There is what is common to the two terms, okay? Here's what's left, okay, after I factor that out. So what I have now is 15,000, 1.09 squared, and now another 1.09. So this will be 15,000, and as promised, 1.09 to the exponent of 3, okay, matching the year. Okay, so let's move on and I'll show you how we are going to use those ideas, okay, moving forward with the graphing and the equation of the functions. So we're going to fill in a table here just like we did with the simple interest, but now this is based on compound interest. So the value of the bond each year is the following. So you'll see that it's 15,000 here, and again 1.09. This will be to the exponent of 4, and again you'll see that that number matches the year number, okay, for this example. So I can go through and fill in all of these expressions, just making sure the exponent is matching the year number here. Okay, so 15,000, 1.09 to the exponent of 6. Okay, and then they even have a generic or general case at the very bottom of the chart here, where I will just be putting a variable of n in for the expression. So this would be 15,000, 1.09 to the exponent of n, and n is any given year. Now, when I do these calculations, okay, what you have to be really careful of is, for example, when I do my calculation for year 4, what I want to do is I want to do the 1.09 to the exponent of 4 first, take that value, and then multiply it by 15,000. Do not multiply the 15,000 by 1.09 first and then raise it to the exponent of 4. Again, why we don't do that is because that exponent of 4, okay, only belongs to the 1.09. So again, 1.09 to the exponent of 4 first, then take that value and multiply by 15,000. Okay, and when you do that, okay, what I get as my answer is going to be $21,173.72. Okay. When I move on to year 5, again, I want to do the 1.09 to the exponent of 5 first. Take that value and multiply it by the 15,000, okay, and that will give me a total of $23,079.36. Okay, so I use that same process the whole way through the chart. So it's the 1.09 to the exponent of the year first, and then multiply by the 15,000. So moving down here, I will show you the totals, okay, that we want to be entering in the amount column. And then we can move on to the graphing and the comparison of the two types of interest, and then you'll clearly see the different shapes, okay, that the two functions take once I put them on an x and y axis. Okay, so any questions on those calculations, again, make sure you forward them to me and I will get back to you and help you understand it a little bit clearer. Okay, so at the end here, okay, again, the value of the bond at the end of n years is always going to be 15,000, 1.09 to the exponent of n. So n and n. Okay, again, they match up. So what they want us to do now is plot the data, okay, from the two tables, the simple interest versus the compound interest. Okay, so simple interest, again, I will do in red, okay, and the compound in blue, and then hopefully you will see the differences in the shapes. Okay, so 15,000. Okay, so I'm getting these points from the table. So the first one would be 0 and 15,000, because at time 0, before I've done anything with the bonds, I started with $15,000. Okay, then I would go to end of year 1, so 1 comma and then 16,350. That comes from the table of simple interest on the previous page, page 292. Okay, so again, if you're confused where I'm getting that from, okay, is right here. So this will be the first point I'm going to do, and then I'm just going to be plotting all of these points individually. Okay, where end of year, okay, is going to be my x value, and this will be my y value. Okay, so that's where I'm getting the ordered pairs from on the graph here. So year 1, 16,000, 1350. Okay, so when I do that, okay, so 1 right about there. Okay, and then year 2, 17,000, 750. Okay, so we're both there. Okay, year 3, 19,000. Year 3, where am I? Right there. So year 3, 19,000. Okay, again, you'll see that the shape it's taking here is a line. Okay, so it should be very, very linear in appearance. Year 4, just over 20,000. Okay, so year 4, just over 20,000. There. Okay. And what do I have? Year 5, 21,750. So year 5, 21,750. Okay. Year 6, 23,000. So year 6, 23,000. And year 7, 24, 450. And then finally, 8, 25,800. So 24, 25, 25,000, and 800. Okay, so you can see that the shape there of those red dots is pretty linear, and that's exactly in F. Okay, what they are saying it will be. Okay, linear right there for our simple interest. Now, when I go and do the compound interest, okay, those values I'm going to get from this table right here. Okay, again, where the value of the bond is going to be my x coordinate, and the amount will be my y coordinate. Okay, I'm just going to plot those points now, and you'll see the difference. And again, the shape should be an exponential graph. Okay, rising more quickly as we move to the right or as the years progress. Okay, so again, they will start at the same place because at time 0 they had 15,000. So at the very beginning after year 1, they're almost identical. Okay, they are actually at 16,350. Then there's a little bit of separation. Okay, after year 1. And then that separation just grows from year to year. Okay, so after year 3, okay, a little bit more separation. Year 4, okay, a little bit greater separation between the points, and that's all that happens as we move through from, like I said, year to year. Okay, and I'm just going to plot these points as we move through here. And it's just about done. 2 more points for year 7 here is 27. And then 8 is just about 30. Okay, and there you go. Okay, so there are the 2 different types of shapes. So again, really, okay, if for some people sometimes tough to see. Okay, so what we should see is the following. Okay, this is what the simple interest looks like, and the exponential, okay, or the compound interest, okay, looks like this. It's taking on the graph of an exponential function. Okay, so it says the final amount a can be written as an exponential function of the number of years n in the form a is equal to ab to the n. Okay, state the values of a and b. So the value of a, okay, will simply be 15,000. That's your initial amount that you're investing, and b is the 1.09. Okay, so when I go and write the equation there, it'll be a is equal to 15,000, 1.09 to the exponent of n, okay, which is what they told me it would be at the beginning of the question. So again, how do a and b relate to this scenario? Well, again, a, okay, that is your initial investment. Okay, so how much money you start with. And the value of b, b is 1 plus your annual interest rate. Okay, and that's how we get those values, and that's how they relate to the question. Okay, so let's move on, okay, and take a look at reading some graphs, and then we'll get some practice at writing equations and those types of things. Okay, so G says the difference between exponential growth and linear growth is more apparent as we extend the graph more years, okay, and beyond 20. Okay, so what they've done is just taken what we did on the last page and added more years. Okay, move the graph further and further to the right. Use the compound interest graph to estimate the number of years it would take for the initial investment of $15,000 to increase to $50,000 and then $100,000. So $50,000, okay, when I go to the chart and I want to know $50,000, okay, I find $50,000 right there, and they're talking about the exponential, so I just travel along, okay, the axis until I hit the exponential graph there, and then I want to read the number of years that correlates to, okay, which appears to be 14. Okay, so this is going to be 14 years right there. Okay, for $100,000, okay, so you'd go all the way up to $100,000. Okay, that's the amount. Same thing. I'm going to go all the way across, okay, till I intersect or find that value on the graph. Okay, and then I'm going to drop down, and I am going to read that corresponding value there, which appears to be 22 years. Okay, so this is 22 years, and they state that an algebraic solution will be developed later in the lesson, but right now just reading graphs. Okay, it says consider an investment of $30,000 compounded annually at 5% per annum. Write an exponential function which will represent the final amount after n years. So all they've really done there is they have changed the initial investment, haven't they, to $30,000. So the amount in this case, or this scenario, would just be the $30,000. There's your initial investment. And now they've also actually, I apologize, changed the percentage. So now it's 1.05. Okay, I add the 5% to the number 1. And then that has to be to the exponent of n. Okay, I consider an investment of $750 compounded annually at 3.5%. Write the exponential function, which will represent $a after n years. So same kind of idea. My initial investment this time is $750. I'm going to add 3.5% to 1. So that's going to be 1.035. And that's to the exponent of n as well. Okay, so they want me to come up with a general equation now, okay, where A is always going to be the final amount, P is your principal amount, I is the annual interest rate, and N is the number of years. So it's going to look like this, P1 plus whatever your interest rate is to the exponent of n. Okay, and there's your compound interest formula. You'll see that when I go to the next page, okay, that is the formula that is right there. So again, we need to know that formula, okay, and we need to be very aware of what these 4 variables stand for and represent in the equation. Now they are saying, and like you saw on the graph, that it does take on the form of an exponential function. So remember that this is like your a value in the exponential, and this is basically your b value, okay, and this n is like the exponent of x. So it is like a and then b to the exponent of x. That's why it does take on the shape of an exponential function. Okay. Let's try some questions here, okay, and talk about borrowing money and see how we do. When an amount of money is borrowed, interest is charged for the use of that money for a certain fixed period of time. If the loan is paid off in one payment at the end of the loan period, then the compound interest formula can be used. If repayments are made on a regular basis, the compound interest formula cannot be used, okay? Now, Travis borrows $2,000, right, from his parents and agrees to pay off the loan in one payment, okay? So that's why we can use this formula when he graduates. Interest is charged at 3% per annum, okay? So that's what the /A means, per annum, so per year, compounded annually. How much money does he owe at the end of the second year? Okay, so I'm going to treat this like a compound interest calculation, which it is, even though it's a loan, okay? Like so, and then I fill in the values that I know. So the amount that he's going to owe is equal to $2,000 because that's the initial amount that he borrows. And now I get 1.035, okay, because I add 3.5% to the number 1, and he's doing that for 2 years. So again, when I do that calculation, please remember that I do this part of the calculation first, and then I multiply it by the 2,000. Okay, the exponent of 2 does not belong to the 2,000. So it'll be 1.035 to the exponent of 2 times 2,000, okay, and they want that rounded to the nearest two decimal places, so the amount will be $2,142.45. Okay. B says, if he paid off the loan after 2 years, how much interest would he have paid? Well, he has to pay back a total of $2,142.25. Okay, and it should be 45 cents. I apologize. So get rid of this. 45 cents, 2142, 45 cents, and I am going to subtract the original $2,000 that he borrowed, okay? So when I do that, that means he paid an extra $142, okay, and 45 cents. Now, part C, Travis was not able to pay off the loan after 2 years, and he eventually paid off the loan. He had paid $458 in interest. Write an exponential equation whose solution gives the time period of the loan. Well, if he pays $458 in interest, okay, that means his total payment back to his parents would be that amount plus the $2,000 he owed. So he actually pays in the end $2,458. Okay, that is going to equal, here's the original scenario, okay, or original equation we were dealing with. So in that case, I would be solving for what n is. Okay, I want to know the time period, okay, of the loan, which is going to be that value n right there. And that's what they're asking me to do, solve the equation algebraically to determine the time period for the loan. Okay, so again, I'll set up the question. Then I'm going to work off of 2,458 equals 2,000, 1.035 to the exponent of n. Okay, now what I'm going to do first is divide both sides of the equation by 2,000. Okay, I want to get the 2,000 out of the right-hand side of the equation. So that's the first thing I'm going to do. So I take 2,458, divide by 2,000. Okay, and that gives me 1.229. So I now have 1.229 equaling 1.035 to the exponent of n. Okay, so that's what I have. I am now going to convert that exponential equation to a log equation. Okay, so we remember how to go back and forth between exponential and log functions. So if I write this as a log equation now, it's going to be log base 1.035, okay, with a base of 1.229 equals n. Now the reason I want to write it that way is because now I can use change of base, okay, to use my calculator to help me calculate this. So it would be the log of 1.229, okay, all over the log of 1.035, and that will give me my value of n, okay, when I do that. So when I do that, okay, it's to solve the equation for the time period. I am going to get, so log of 1.229 divided by the log of 1.035, okay, and for that I get a value of, okay, n is equal to 5.99, okay, etc. Okay, so that is a 6-year loan, okay, that we're dealing with there. As always, any questions, okay, send them to me and I'll get back to you with maybe a better explanation or more detail, okay, whatever you guys need. All right, so the next 2 pages or page and a half here, okay, is what's really, really kind of important here. We're going to be doing a lot of calculations with this compound interest formula. And again, I will point out here, okay, what's important. Now, in these questions with compound interest, you're going to see these key words, okay? We don't always compound interest annually. Okay, sometimes we do, but sometimes it's semi-annually, okay, which means twice a year, or they'll say quarterly, 4 times a year, or monthly, 12 times a year, okay, etc. So when I go into the formula that we've seen before, okay, the 2 variables that you always want to be really careful of are the interest rate, okay, and the number of compounding periods, okay. You always have to be very careful when you're substituting those values into the equation, okay, and that's what this guy right here is kind of warning you about, okay. I is not always the annual interest rate, okay, it's not that, and n is not always the number of years, okay. So we're going to have to take a look at how we calculate those values in these questions, so be very careful of those things. And again, I will let you know where we need to be cautious of those and how we get the correct values for our equation. So in class example 3 here, it says if the annual rate of interest is 6% per annum. So again, the bank is going to give you 6% for the whole year. State the interest rate for each compounding period, okay? And then also they want the total number of compounding periods. So you'll see here, they're saying you're compounding your interest semi-annually. You're going to collect your interest twice a year, and you're going to do that for 5 years, right? So my interest rate then, that's what they want. The interest rate every time I calculate interest is going to be what? Well, semi-annually is twice a year. They're giving me 6% for the full year. So it would be 6%, right, divided by 2. So my interest rate would be 3%. I'd get 3% every time I'm calculating interest. And I'm going to do it how often? Well, twice a year, because I'm getting it every half a year. So twice a year for 5 years. So the number of periods here where I'm calculating interest, okay, would be 2 times a year for 5 years. So I'm going to calculate or collect interest 10 times. In B, now we're compounding monthly, and we're doing that for 6 years. So I want to calculate the interest rate. So the interest rate, again, is they're giving me 6% for the full year. So I'm going to take that 6% and I'm going to divide it by 12. Okay, and that is going to give me 0.5%, 0.5%. Now the number of periods where I'm calculating interest, okay, well, what will that be? I'm doing it 12 times a year, right, every month, but I'm doing that for 6 years. So 12 times 6 is 72. So I'm going to have 72 periods where I'm collecting interest, okay? So let's see if we can take that idea and extend it to the table or the chart below, and then we'll do a couple questions, and then that's it. Then you're free to practice it and see if you can get the general idea, okay? So in the next question, we're starting with $1,000, a nice round number, and we're doing that for 5 years, okay? Investing it for 5 years, and the annual rate of interest is 6%. So again, the bank is giving me 6% for the full year. I have to fill in all these columns and rows based on that information. So if I'm going to compound my interest annually, okay, that means how many times a year? Just once a year. So the number of total compounding periods would be what? Well, it would be 5 because I'm investing the money for 5 years. So once a year for 5 years. Now the interest rate every time I collect interest is just going to be 6%, isn't it? Because they're giving me 6% for the full year. So every time I collect interest at the end of the year, I'm going to get 6%. So in my formula, using your compound interest formula, it's going to look like this, right? 1,000, there's the initial investment, 1.06, I get that by going 1 plus 0.06 and to the exponent of 5. Now, I do that calculation, okay, so remember 1.06 to the exponent of 5 first times 1,000. This will give me a total amount of $1,338.23. Okay, now I move on to semi-annually. Okay, well, semi-annually means what? Twice a year. So twice a year for 5 years means there's going to be 10 compounding interest periods. Now, I'm getting interest of 6% for the full year, but I'm collecting interest twice a year. So they're only going to give me 3%, okay, every time I collect interest. So that's where, when I go into my formula, okay, watch carefully now, this is actually 1.03, okay, that comes from right here. So 1.03, and now the exponent of n is the number of interest periods, which is 10. Okay, so 10 interest periods, which comes from the total number of compounding periods. So now on my calculator, 1.03 to the exponent of 10 times the 1,000, okay, and I will get a total of $1,343.92. Okay. Quarterly, okay, quarterly means 4 times a year, okay, every 3 months. So if I'm collecting interest 4 times in 1 year and I'm investing for 5 years, that means I'm going to have 20 times that I'm collecting interest. Now, the interest every time I collect it is going to be 6% divided by 4. So 6 divided by 4 is 1.5. So I'm getting 1.5% every time I collect interest. So how does that affect my equation? Well, it's $1,000. Now this is going to be 1.05 0.015. So there's the 1.5%, and the number of interest periods is 20. So this time 1.015 to the exponent of 20 times 1,000, okay, and I get $1,346.86. So you can see the more interest periods I have in general, okay, I make a little more money, not a ton, but a little bit. Now monthly means what? Every month. So in a year, that would be 12 times in a year. And 12 times in a year over 5 years will give me 60 total times of collecting interest. So the interest every time I do that is going to be 6% divided by 12, and that is going to give me 0.5%. Okay, so 0.5%. So in my equation now, this is going to be 1.005 to the exponent of 60. Okay, so calculate that, 1.005 exponent of 60 times 1,000, okay, and I get a total of $1,348.85. Okay, so hopefully how I got the values of I and N are somewhat clear. Okay, and again, we'll walk through them in these next two questions and see if it is making sense. So it says Christine invested $2,500 for 4 years. Okay, so again, always feel free to underline the important thing. So we're investing for 4 years. There's how much she's investing. She's compounding semi-annually, so twice a year. Okay, and they want the annual rate of interest. That's what they're after. Okay, and she actually got this much in interest. So we'll see how that plays into the calculation. So her final amount, right? We know that we have to use the formula A is equal to P 1 plus I to the exponent of N. So A is the final amount. Well, the final amount will be how much she started with plus the amount of interest that she accumulated, which is $843.26. Okay, so that is going to be a total amount of $3,343.26. Okay, so that's how much we're going to put in for A. Now P, her principal amount, well, that's what she started with, so that's her 2,500. I, that's what we're after. Okay, we don't know what that is. And N, well, N is the number of compounding periods. So how do I get that? Well, semi-annually is twice a year. The number of years is 4, so 4 times 2 is 8. There will be 8 interest periods. So start with your formula. A is equal to P 1 plus I to the exponent of N, and fill in the variables that you know, or the values for the variables that we know. We calculated that final amount to be $3,343.26. The principal amount was $2,500. This is going to be 1 plus I and to the exponent of N, which is 8. Okay, so just like we did in other questions, what I'm going to do first here is divide both sides of the equation by 2,500. So take your $3,343.26 and divide by 2,500. Okay, when you do that, you are going to get 1.337304, okay, and that is going to be equal to 1 plus I to the exponent of 8. Okay, so what we want to do at this point is get rid of the exponent of 8. So you'll remember that what we did in previous lessons is we took this side, and to get rid of it, I would raise it to the exponent of 1 over 8. Okay, if I do that, I have to do the same thing to this side. Raise both sides of the equation to exponent of 1 over 8. Okay, so what that'll do, and that's the same as taking the 8th root, right, of each side. So when I do that, okay, what I can do is the following. Okay, so I can take the 1.337, and if you remember under your math feature, okay, you have the ability to take the root, any index that you want, and that will give me a value of 1.037, and that will leave you with 1 plus I on the right hand side of the equation, okay, because you multiply those exponents together, 8 times 1 over 8, which will leave you with 1. Now I want I, so I'm going to subtract 1 from both sides, okay, and that will give you 0.037 is equal to I, the interest rate. Now most people are very happy at this point, okay, because they've solved for I, but remember that's my interest rate for this question, which is semi-annually, okay. I want the annual rate of interest. Okay, if you read the question, right, they want the annual rate of interest right there. So what I have to do is I have to take that, and if this is semi-annual, I'll multiply it by 2 to get the annual interest rate. So take your 0.037, multiply by 2, okay, and you will get 7.4%. So 0.074, okay, which is the same as 7.4, okay, when I write it as a percentage. So there is the annual rate of interest. Okay, so always some small little details in the question you gotta be very, very careful of. Okay, last one here. Andrea borrows $7,500 from her parents to buy a new car. Her parents charge her interest at the rate of 4% per annum. Okay, so again, 4% per year. Okay, she borrows $7,500, but she's compounded quarterly here, okay, the interest that she's charged. When she pays off the loan, she pays $785 in interest. What was the length of her loan? So the length of her loan is N, okay, the number, okay? That's what we're after here. So the amount that she owes is going to be the $7,500 she borrowed plus the interest that she owes, which was $785, okay? So her final amount that she owes her parents is $8,285. The principal amount of her loan was $7,500, and the interest rate is going to be what? Well, 4% a year compounded quarterly, so divide 4% by 4 and you get 1%, okay, which is 0.01 as a decimal. Okay, so again, I start by writing out my equation. A is equal to P 1 plus I to the exponent of N. The amount is 8,285. Okay, the amount that she originally borrowed was 7,500, and this time 1 plus a 0.01 to the exponent of N. Okay, so if I just simplify what's inside the brackets there, I will have 1.01 to the exponent of N. So this time I'm after that variable N. First thing again, divide both sides by 7,500. So take your 8,285 and divide by 7,500. Okay, and when I do that, I will get 1.1046 repeating. Okay, and that will leave me with 1.01 to the exponent of N. Okay, I'm not going to round anything until the very end of the question. So what I want to do now is convert this from exponential to log form. Okay, so this is going to be log base 1.01 of the 1.1046 repeating, okay, will equal N. So when I use my calculator to help me solve this, I'm going to go log of the 1.1046 repeating, and that will be all over the log of 1.01. That will tell me what N is equal to, okay? So when I do that, okay, you will see that N in this case equals 10, okay? So 10 is equal to N. Now, what was N though? We are compounding quarterly. So that's 10 quarters, okay? 10 quarters of years. So 4 quarters would make up 1 year, right? So 4 quarters is 1 year. Another 4 quarters is a second year. That's 8 of the quarters. I have 2 quarters left over. So this, in essence, therefore, is 2.5 years. Okay, that's how long it took. So just think about the years broken up into quarters, because that's how often I'm compounding the interest. Okay, so I have 10 quarters. Okay, 4 of the quarters makes 1 year. Another 4 quarters makes another year. So 2 full years. I've used 8 of the quarters, 2 quarters left. Well, 2 quarters is a half. So that's how I get the half year. Okay, so take some time with this stuff. Really work through them. Read carefully, read slowly. Make sure you always know the values of A, P, I, and N when you are writing out the equation to solve. And always be very careful of I and N. Okay, any questions on those values?